Good day, ladies and gentlemen personalities. Today we are going to be dealing with trigonometry, and we are going to deal with particular solutions of the trigonometric equations. Particular solutions of the trigonometric equations. There are general solutions, there are particular solutions. So now we are going to deal with particular solutions. Other people call it specific solutions of a trigonometric equation. Now let us go ahead and see what we are going to do. So let's say you've been requested to solve for x, and then you've been given 2 sine x, which is equal to 1, and then they say solve for, so okay, let's state it here, solve for x, for x which is an element of 0 degrees up to 360 degrees. Okay, so how do you go about doing that? Okay, first of all, guys, you must make sure that you find what? You find an angle. So how do you find an angle? First of all, you need to divide by 2 both sides. Divide by 2, divide by 2. These 2 will cancel this 2, and then we'll remain with sine x, which is equal to 1 over root 2, right? And then we are going to then have x ref, which is the reference angle, in other words, an angle that we are going to use. And then the x ref is going to be the reciprocal of sine evaluated at 1 over, not root 2, it's 2, at 1 over 2. Okay, therefore our x ref is equal to 30 degrees. Okay, so our x ref is equal to 8 degrees. So this angle of x, which is 30 degrees, is the angle that we are going to work with to find a solution that we need. All right, now when you look at this part, there is sine x is equal to 1 over 2. So when you have this sine x is equal to 1 over 2, note that this sine x is what? Is positive. Okay, is positive. And then you must remember that you had something like this, which was called the cast diagram, where you've got all trigonometric functions being what? Being positive here. And then here it's only sine theta that was positive. And then here it was only tan theta that was positive. And then here it is only cos theta that was positive. So for example, here all trigonometric functions are positive. Here sine theta is positive, but tan theta is negative here, and then cos theta is negative here. And then here tan theta is positive, but sine theta is negative here, and then cos theta is negative here. And then also here cos theta is positive, and then all other ones, which means sine theta and tan theta, they are all negative here. And then remember, people used to abbreviate this with all station to Cape Town, or some will say all students take coffee. It's up to them. So when you are doing this kind of thing, it is very important to note here that in the first quadrant, this is quadrant 1, first, all trigonometric functions are positive, and then in a second quadrant it's only sine theta that is positive, and then in a third quadrant is tan theta that is positive, and then lastly in a fourth quadrant is going to be cos theta that is going to be positive. Okay, so when you looked at this, all right, so it is positive. So the question is, in which quadrant is it positive? Okay, it's sine theta. So sine theta is positive in a second quadrant and the first quadrant. So it is positive in a first and then a second quadrant. So what does that mean? That means that your solutions are going to be in two quadrants. They are going to be in the first quadrant and the second quadrant, simply because what we are looking for is positive, and then it is only positive in the first quadrant and the second quadrant. Okay, so now let's find the solution that is in the first quadrant. The solution that is in the first quadrant is x itself. X is equal to 30 degrees, because you just take an angle that is below 90 degrees. Okay, and then in a second quadrant, so if you are in a second quadrant, then you've got x is equal to 180 degrees, okay, minus x ref, okay, and then which is 180 degrees minus what? Minus 30 degrees, which is nothing other than 150 degrees. So the solution for 2 sine x is equal to 1 between 0 and 360 degrees is x is equal to 30 degrees, and it is equal to x is equal to what? Is equal to 150 degrees. So let us test these solutions if they are fine. And remember what we started with initially. Okay, we're going to use this one to test. It's 30. So we're going to our calculator and say sine, and then say 30 degrees. Aha, you find half, which is this one. Okay, and then let's see about 150. Sine 150, sine 150, you get half, which is this one, which means that these are indeed solutions to our problem. Do you guys understand? Okay, so the solution for sine theta, whatever value it has here, if it's positive, then it is in the first quadrant and the second quadrant. So for sine theta or sine x or whatever, their solution is in the first and second quadrant. Okay, and second quadrant. And then in the first quadrant, it's going to be theta is equal to theta ref, and then in the second quadrant, it's going to be theta is equal to 180 degrees minus theta ref. The theta ref is the one that you actually work with. Okay, in this case it's x ref. Okay, so that is what you do for sine theta. Now let us go and look at cos theta and see how that behaves. Okay, so let's say you've got you are solving for x, which is an element of 0 degrees to 360 degrees, and then you've got cos theta, which is equal to 1/2. Again, here you must find theta ref. Okay, so you must find theta ref. Actually, let us actually try and put some steps here. Let's try and put some steps. So step 1, how to solve for an angle, so for theta or whatever, on a certain interval. Okay, so step 1. So what do we do? Find theta ref. Okay, Okay, find the reference angle. Okay, let's do that here. So theta ref is nothing other than the reciprocal of cos evaluated at 1/2, and then what do we get there? We get 60 degrees. So theta ref is equal to 60 degrees. So that is the angle that we are going to use to find the angle that we are looking for. Okay, now step 2, what do we do? Number 2, we must find the quadrant where the solution is. Okay, that is step number 2. Okay, so let's look at this one. This is cos theta is equal to, so here cos theta is positive. So cos theta is positive where we are going to go to the cast diagram. So NB, use cast diagram. This is what this thing is called. It's called cast diagram. Okay, so when you use a cast diagram, you want cos that is positive. You find out that cos is only positive in the first quadrant and in the fourth quadrant. So cos is positive in the first and fourth quadrant. Okay, if you go around 360. Okay, guys, this is not always the case. Sometimes they can say from 0 degrees to 180 degrees. You must know where the buck stops. Okay, it's not one size fits all solution. Okay, so in this particular case, you know that's okay. In the first quadrant, you just take the angle as it is. So the first solution in the first quad, your theta is going to be what? It's going to be theta ref as it is, which is equal to what? Which is equal to 60 degrees. Okay, what about the second quadrant, the fourth quadrant? In the fourth quad, guys, there is 360 minus. This is a 360 minus quadrant. Okay, so basically let me just show you what to use here. So here you use 360. In this fourth quadrant, you always use 360 minus theta. Here you always use 180 degrees plus theta. Here you always use 180 degrees minus theta, and then here you take the angle as it is. Okay, right. So here your theta is going to be 360 degrees minus theta ref. Okay, so which is 360 degrees minus what? Minus 60 degrees, and that will give you 300. So the solution here is 300. So if you can go to the calculator and say cos 300, you must get exactly 1/2. Let's just test it so that some of you will sleep at night. Cos 300 equal to half. Can you see that? And then what about cos 60? Cos 60 is equal to half. So this solution does work. This solution does work. Okay. So around 360, each and every trigonometric function has 2 solutions. Right. Now let us take tan theta. Now let's say we've got tan theta, which is equal to 1/√3, and then you need to solve it. Solve for theta, for theta, which is an element of 0 degrees up to 360 degrees. Okay. Now in this particular case, you still do the same thing. Find the reference angle. Okay, you find the reference angle, which is step 1 Okay, how to find a reference angle? Theta ref is equal to the inverse of tan, not sine, tan evaluated at 1 over root 3. And then if you put this thing on a calculator, you end up with what? You end up with 30 degrees. Okay, and then you must find the quadrant where the solution is. So how do you find that? You look at what you have here. You've got tan theta is equal to 1 over root 3. So tan theta is positive here. Tan theta is positive where? Go back to your cast diagram. Okay, tan theta is positive here. Can you see? The here is where t is in 180 plus. Okay, and then where else? And in the first quadrant. Okay, and then I think by now you have already realized that most of the things, they will always be positive. There will always be solutions on the first quadrant as well, but you must read carefully. It's not always the case. Sometimes they give a question that starts in different quadrant. You will see with the next question. Okay, but if you are looking for solutions within 0 to 60 degrees and then you have been given a positive function, in most cases you will have a solution in the first quadrant. Okay, so you've got a solution in the first quadrant. You've got a solution in where? In there, in a third quadrant. Why? Because tan theta is positive, is greater than 0, which means it's positive. Okay, so here theta is equal to theta ref. You all know that. So that means this is 30 degrees. Now in the third quadrant, what happens? In the third quadrant, you use 180 plus theta. So theta is equal to 108 degrees plus theta ref. Okay, which is 180 degrees plus theta ref. What is theta ref here? Theta ref is 30 degrees, so it's 30 degrees. So you end up with 210 degrees. Okay, so this is a solution in the first quadrant, and this is a solution in the third quadrant. All right, ladies and gentlemen, do you understand? Okay, now, okay, so you said step number 1, you find theta ref. Step number 2, you find a quadrant where the solution is, and then you use the cast diagram. And then step number 3, you must then find your solution. The solution. So it's only 3 steps. Okay, I know you guys like steps. I do not know why, but anyway, now let's take another problem. Solve for x where x is an element of 0 degrees up to 360 degrees. Okay, these problems are very common, guys, when you're writing exams, so make sure that you understand them very well. Okay, and then what is the function that we're given? We're given, or an equation that we're given is 10, where is it? Is 3 10x plus 4 is equal to what? Is equal to 0. Okay, let's have 10 is equal to something. So in order to have this, we're going to have take this 4 into the other side, and then we'll end up with what? With minus 4 here, and then we'll have 3 10x here, right? And then we'll divide by 3 both sides. So we divide by 3 here, we divide by 3 here, we cancel, and then we end up with 10x, which is equal to minus 4 over 3. Okay, so just on normal cases, let's say 4 over 3 minus 4 over 3 minus 4 over 3 minus 4 over 3, it's minus 1.33. Let's just write this in. You will see where we're going to use it. It's minus 1.33 and on and on and on. Okay, we're going to take only 2 3s. Okay, now guys, remember earlier tan was positive. Where is this? We dealt with a problem, and then in that problem, tan was positive. Okay, can you see that? Tan was positive, but now tan here is what? Is negative. Okay, so that means that the trigonometric function will not always be positive. It will sometimes be negative. But don't worry, you're going to use the same cast diagram to find out where tan is negative. Okay, so now one thing, guys, when you are using, okay, let me actually write it down. NB don't include the negative sign when looking for what? For the angles. Okay, so you're going to have x is equal to, and then the reciprocal of tan evaluated at 4/3. Okay, how are we going to take care of this negative? We're just going to see where. Remember, this negative, the job of the negative in trigonometric function is simply to tell us where is this angle located. Okay, so when we do this tan, we end up with something. Now what do we end up with? We end up with 53.13. Okay, you can do that on a calculator. You'll see it's 53.13 degrees. Okay, this is X ref. It's not a solution, it's the reference. It's what we're going to use to find solution. Now, we did find theta ref, which is X ref in this case. So step number 1 is done. All right, let's look at step number 2. What do we do in step number 2? To find the quadrant where the solution is. Okay. Here, tan x is what? Is less than 0. So where is tan less than 0? Here it's only sign that is positive, so tan is less than 0 here. And then here it's positive, so it's also less than 0 here. So your solution are in the second quadrant and what? And fourth. Okay. I want you to note the difference between what we have here and what we had earlier. Okay. Earlier we had theta ref simply being one of the solutions, but here this is not the case. Okay, so you must always be careful. Each and every case has its own merits. Okay, so okay, let's look at the solution in a second quadrant. Solution in a second quadrant, always, guys, you use 180 minus. So you're going to say your x is equal to 180 degrees minus what? Minus 53,13. And then if you minus this on a calculator, what do you get? You get 120. You get 126,87. 126,87 degrees. Okay, guys, this is a new territory, so let's quickly check if this solution is working. Let's go to our calculator, and then let's say, what is this? It's tan. Okay, so if this solution is correct, if we put it here, we must get exactly either this or this. Okay, we won't get this, obviously, for some significance reason. We're gonna get, that is why I did put this number here. So let's see. Tan of 126,126,87. What do you get? Aha, can you see? It's minus 1.33, which is exactly this one. Does it make sense? All right. So this means that the solution is correct. Guys, when you are supposed to solve, you will always know what the answer is. Whether your answer is positive or negative. So make sure, right? Make sure, ladies and gentlemen, personalities, that you check your solution if your solution is right or wrong, so that you can go to the next question having that assurance that you will find the correct answer. Okay, so we said the first solution is in the second quadrant. Now this, what about the other one? The other one is in the fourth quadrant. Okay, we've already said that in the fourth quadrant we have 360 minus. We always use 360 minus. Okay, so we're going to have x, which is equal to 360 degrees minus theta ref. And then what is theta ref in this case is 53,13. And then what we get, you can check with your calculator, we get 306,87 degrees. This is degrees. Okay, now is this solution correct? Yes, our calculator will actually help us in that regard. We say tangent of 306,87, 306,87, and then what do we get? We get minus 130. Can you see? Yes, which means our solution is correct. All right, our solution is correct. Let us do the last one, and then close shops. Let's say they say they wanted sine theta, which is equal to 1/2, but now they say for theta, let's say they say for theta that is between, say, 90 degrees and what? And 90 degrees and 270 degrees. Okay, I'm just trying to show you that it's not always 0 and 360. You do get a lot of questions that has got that kind of an interval, but you can have another interval. Okay, so theta ref here, we all know that our theta ref is going to be sine, the reciprocal of sine evaluated at 1/2, which is going to give us 30 degrees. Okay, now between 90, remember guys, this is 0 degrees, right? And then this is 90 degrees, this is 80 degrees, and then this is what? 270 degrees, and this is what? This is 360 degrees. So they want a solution between 90 and what? And 360. So a solution of this equation in this, either here or here or here, wherever it is, but not here. Okay, so sine theta in this case is what? Is positive. Can you see that? Yes, it is positive. And then you know that sine theta is only positive in the first quadrant and the second quadrant, but we're not going to include the first quadrant. Why? Because it's not part of this interval that we are given. We're only going to include the second quadrant. So because of that, the solution is only where? In the second quadrant, because in the third quadrant the solution is not there, because sine is not positive here. And then the solution is not on the fourth quadrant because sine is not positive here, but it is there on the second quadrant. So you then get theta, which is equal to 180 degrees minus 30 degrees is equal to 150 degrees. So you only have 150 degrees here. So basically, when you are saying solve for theta for this angle, you are saying find the solutions for me. Guys, remember, when you are looking at the graph of sine, we haven't done the graph of sine, but when you're just looking at it, you will see when you do it that the graph of sine is between 1 and minus 1, right? And then minus 1. So what will happen is when you pick a point, so this is half, so half is somewhere here. Can you see that? So your sine function will go like this, and it will go on and on and on and continue this side and also go. Okay, so you can see that when you've got half here, and then you are trying to find the solutions. There is a solution here where it meets, and then there's a solution here, and then here, and then here. There are infinitely many solutions, but okay, this is 360 degrees. Earlier we wanted solutions, the only solutions that lie between 0 and 360. Okay, and then now in this solution we only, so we'll say 90 is here, 90 is here. So we only want the solution that lies between 90 and 360. So in this case, it's which one? It's only this one. It's 1. Half touches this graph only here. But if you say from 0 to 360 degrees, it touches the graph twice. That is why we had 2 solutions earlier. But we're going to go deep into it earlier. And then when we want all the solutions that touches every point, then that is where we're speaking about general solutions. But that is also something that we'll speak about. Ladies and gentlemen, personalities, this is what? This is solving for theta, but not just solving for theta, solving for theta between certain interval, and then seeing how you find solutions in different quadrants. Okay, let's just go back to our what to call, to our homemade steps. We say if you are supposed to find x within a certain interval, first step number 1 is to find theta ref. When you found theta ref, then find out which quadrant where you find your solution, and then in order to do this, you use what? You use a cast diagram. And then when you've done that, then find the solutions. And then you've been given that in a first quadrant, you just take theta ref as it is. If it is in the second quadrant, you always use 180 degrees minus theta. If you are in the tangent, if you are in the third quadrant, you always use 180 degrees plus theta. And if you are in the fourth quadrant, you always use 360 degrees minus theta. Right? So ladies and gentlemen, this is how you summarize how to solve for x for a second quadrant. I do believe that none of you will suffer with this kind of exercises anymore. Thank you very much. If you've got questions, or if there is somewhere where we went wrong, make sure that you ask us on the comment section below. Thank you very much. And ladies and gentlemen, this is particular solutions or specific solutions of quadratic, of trigonometric equation. Thank you very much, and goodbye.